Hello students, welcome to my channel Engineering Education. Please subscribe my channel. Thank you. In this video we are going to solve problem 3.8, chapter number 3, Reversible and Irreversible Processes, from the book Applied Thermodynamics by Eastop and McConkey. Statement of the problem is 1 kilogram of air at 1 bar 15 degrees centigrade is compressed reversibly and adiabatically to a pressure of 4 bar. Calculate the final temperature and the work input. So first of all we will write the given data. We have given that the mass of the air is 1 kilogram and its initial pressure at state 1, that is P1, is equal to 1 bar, and temperature T1 is 15 degree centigrade. The process is reversible and adiabatic process. Similarly, the pressure P2 is 4 bar. We are required to find two quantities. First is the final temperature, that is T2, and second we have to find the work input from 1 to 2. The schematic or the properties diagram, or we can also say generally that the thermodynamic properties diagram, and specifically we can say that this is the pressure and specific volume diagram for reversible adiabatic thermodynamic process. This is state 1 and this is state 2. We can express adiabatic curve with the expression PV power gamma is equal to constant, where P is the pressure, V is the specific volume, and gamma is the adiabatic index, or it is the ratio of specific heat capacities, and gamma is Cp by Cv, and the value of gamma for air is 1.4. It is a unitless quantity or term. So coming to the solution of the problem, the process is compression basically and adiabatic compression. So to find first the temperature after compression, that is T2, we have the temperature ratio T2 by T1 is equal to, temperature ratio is linked with pressure ratio P2 by P1 for adiabatic thermodynamic process, power gamma minus 1 by gamma. So rearranging this equation, we can write the value or the expression for T2, and it is equal to T1 into P2 by P1 power gamma minus 1 by gamma. So putting the values, T1 is 15 degrees centigrade, so converting into Kelvin it will become 288 Kelvin. P2 is 4 bar and P1 is 1 bar. These are the temperatures P1 and P2 converted to Pascal. 1 Pascal is equal to Newton per square meter. So also the value of gamma is 1.4 minus 1 over 1.4. So simplifying this, the value of T2 comes out 428 Kelvin, or in degree centigrade it is 155 degree centigrade. Also, to find the value of work input, for that we have the non-flow equation, that is Q plus W is equal to U2 minus U1. So for reversible adiabatic process, we know that Q is 0, and from Joule's law we know that specific internal energy is CV times temperature. So for state 1 it will become U1 is equal to CV T1, and for state 2 it will become U2 is equal to CV T2. So W will be equal to simply U2 minus U1. U2 is CV T2, we will common CV, it will become T2 minus T1. So here T1 and T2 are known, and the value of CV is given, and it is in text of the book. Its value is 0.718 kilojoule per kilogram per Kelvin. So putting the values in this expression, W is equal to CV value is 0.718 kilojoule per kilogram per Kelvin. T2 value is calculated here, and it is 428 Kelvin, and T1 is 288 Kelvin. So simplifying this, we get 100.5 kilojoule per kilogram. So in this problem you are required to find the final temperature after compression, that is 155 degrees centigrade, and the work input required during the compression process is 100.5 kilojoule per kilogram. So this is all about the solution of problem 3.8. Thanks for watching. Please like and comment on my videos. Also subscribe my channel to get new videos.